Hello, everyone. Thank you for joining our webinar on dependency injection with Spring. Catalin will start his presentation in about a minute. Until then, I just wanted to cover some ground rules. So in the first part, we're gonna have a bit of theoretical aspects with regard to Spring, but most of our webinar will be focused on practice and showing you various code demonstrations. Our suggestion is that at the end of the FDO webinar, if you have any questions or anything like that, Catalin has set aside some time for any Q&As. So any questions you might have, please reserve them for the end of the webinar and use the chat message to type them, and Catalin will answer every single one of them. So without any further ado, I'd like to invite Catalin to start the webinar. Catalin?
Hello. Hello, everyone. Thank you, Alex, for the introduction. So I'm Catalin Tudose. I'm a Luxoft employee. I act here as the trainer and expert. We are going to spend today 1 hour or a little more than 1 hour to discuss about the basis of the Spring, which is the dependency injection. As Alex was also saying, we are going to briefly introduce some conceptual basis of the Spring, and we are going to spend most of our time with practical application, practical examples that we are going to discuss together. Of course, we need some conceptual introduction, and this is the first part of our webinar. What is the Spring framework? What is it if you are not familiar? It is a lightweight, but at the same time flexible and universal framework. A framework is intended to help you build some application. So if you would like to create your own application, a framework means in general that it will provide you a skeleton for developing that application. It is like a building having a skeleton, and once the skeleton is ready, you will be able to add your own business logic and to continue the development of the application. It is important to mention that the Spring framework is open source code. This means that it is available for everyone to download and to have a look inside to understand how the designers and the developers of the Spring framework have created it. And it is an application framework, meaning that it is not designed to serve some layer of the application. It can be used at any level, at any layer of developing an application. Overall, Spring includes a lot of separate frameworks, but no matter what you are going to choose to do, you will always need to understand and to put in practice this dependency injection that we are going to discuss about today. Here, in order to even better understand what a framework means, we are providing some pictures showing the difference between a library and a framework. If we are talking about a library, of course, a library is created and designed in order to help us solve some problem. It means that we are developing an application and we are delegating solving some part of that application to this library. But it is important to point out that it is our code that is driving the application. So our code is calling the library, and the library solves some part of the problem, and then the control gets back to our code. For the framework, it is vice versa. We're saying that the framework is providing us a skeleton for building the application. It means that overall, it is the framework that is calling our code, and it is the framework that is driving or that is controlling the way our application runs. Of course, a framework may contain and may use a few library functions. What is specific about the Spring framework? it is developed specially for the Java platform. So it is the Spring framework that is taking care of handling the infrastructure, or the skeleton, if you want to use the same analogy that we have provided before, so that you as developer can focus on your application. Also, it is important, and we have to underline the fact that you can build your application from plain old Java objects. So you may have some old style Java classes, and you would like to make them the building blocks of your application. This means that you can handle them to the Spring framework and require Spring to create the skeleton for you. Let's have a look here at how we have arrived to this idea of Spring taking the control. Remember, we are talking about dependency injection. And one simple starting example is that we have two classes that have a dependency between them. What we see here is something simple and classical at the same time. We have a person and we have a company, and of course there is a dependency, or we may say it is a connection between them. The person works for a company, so there is a dependency between the person and the company. Once we have created the person, and you see here the public constructor of the person class, we also have to create the company that that person is working for. So here at the level of the constructor, we are practically injecting this dependency between the person and the company. Does it work? Yes, it works, but there may be some issues. The problems are that the two classes are directly dependent. Here named A or B, or here person and company, the class are depending on each other. So they are tightly coupled. It is impossible to test A separately from class B. This means that when you would like to test this person class, you will always have to create a company and to make the dependency between these objects and these classes and to test them together. Then the lifetime of the object B, which was company in our case, depends on A, which was person in our case. So you see that this company has been created here at the level of the constructor of the person class. So as we are saying here, it is impossible to use the B object in other places. Its lifetime depends on this person class or this person object, so it cannot be reused. And it is not possible to replace B by another implementation. You have just created and initialized it here, so it will remain here. All these things are disadvantages, because we may know that we always want our classes or our modules, if we are talking about a larger application, to be not tightly coupled. So they must be as independent as possible. So what is this dependency injection, known as inversion of control, and how can we move to a better approach using the Spring framework? Of course, we need some dependency between objects, and we have seen in our example that the objects are defining their dependencies. So the person will know that it needs a company, and it is working with that company. But we would like to change things. We would like to change things in order not to make the person object initializing its dependency. Instead of the programmer controlling the creation and the dependencies between objects, we may imagine that we have those objects inserted into a container. And it is the container that is taking the control. From here, the idea of this inversion of control or dependency injection. These are two labels for the same idea. When we say inversion of control, as we're explaining, we imagine that the objects are inserted into a container, and the container will take the control, will create the objects, will create their lifetime, will control their lifetime, and will also manage the dependencies between them. From here, this concept of dependency injection. So let's have a first look at how such an example using the Spring framework looks like. You see here we have the same person and company classes, but we do not have any more dependency between them at the level of the code. So this person and this company classes are pure objects. We don't see any dependency created at their level. We may see that they are plain old Java objects. So like the Java old times when we are creating classes and we're not mixing them in any way, or we may shortly name them POJOs. So we have decoupled them. There is no dependency created at the level of the code. But we still need to work with some objects and to handle them to the container that we have mentioned, to ask that container to create them, and to manage the dependencies or the dependency between them. How does it look like here? You have here into this application context.xml. It is the part that is handled to the Spring framework in order that it knows how to take control. The Spring framework will understand that into its container, it has to create a bin, Smith, belonging to this class person, and it has to create a bin, Luxoft company, belonging to this class company. It will have to configure this class company and to inject here, you see property name company references Luxoft company, to inject here the dependency between person and company. But we do not clutter our code with these dependencies any longer. Let's have a look at the practical part. Just a moment, please. Okay, we have commuted here to our first example in the Spring framework. Let's have a look first of all at the person and at the company classes. We see this is a very simple class. It has a name and a getter and a setter. The company has a name and a getter and a setter for that name. And the person has a name and the company that he or she is working for, together with getters and setters. So these are very simple classes. These are plain old Java objects or POJOs. So here inside the code, we do not have any dependency. Where do our dependencies reside? Our dependencies reside into this XML file. Here we are showing exactly what we're saying a little earlier and presenting into our PowerPoint. We have two bins or two objects. This Luxoft company bin, which has a property name that is initialized. So it means for the container that when it will take the control, it will understand that it has to create this bin and to configure it accordingly so that the name of the company is Luxoft. And here, it is the second bin that will arrive under the control of the container. The bin with the ID Smith will belong to the person class, and the container will take control, will create it, will configure it, and it will provide the name John Smith, and the company will reference this Luxoft company created here. Okay, how do we instruct the container to take control? We look here into this main class. This is our main application that is using the classes and the configuration that we have presented. What do we have here? We do have an application context. So we tell here to the Spring framework to use this context and to load what is there from this dependencies application context XML. So whenever we'll start this application, the container will take the control and will say, okay, I have some instructions, and it will look here and it will load what it is indicated here. And in order to show that this is really happening, once we have loaded the context here, we come here and we ask, hey, context, can you please give me the bin with the name Smith? This is the instruction. We see here that we are not creating the person by ourselves. We see here that we're not saying something like person Smith equals new person, meaning call of the constructor, and eventually to provide some parameters. We are simply addressing to the container and we are asking this container, hello, do you have a bin with the name Smith? And once we'll obtain this bin Smith, we are going to address to it. And in order to prove the fact that everything has been correctly initialized and that the dependencies have been correctly loaded and injected, we are going to ask Smith, what company are you working for? So that will show that both the Smith and the Luxoft company bins have been loaded and created, loaded, and the dependency between them has been created. Let's have a look here now, and we have this main class, and we are going to run it. And indeed, when we are asking Smith, what company are you working for? It will show Luxoft, meaning that the container has been correctly configured, has correctly created the bins and the dependencies between them. I'll have another look at the slides, and then we are going to work on the code. So here, looking back at the slides, we see how we have made the step between working with the dependencies inside the code and working with the inversion of the control or dependency injection principle. We have started with this traditional approach when we had to describe the dependencies inside the code, and we have moved to the inversion of control where objects didn't know anything about each other. We have a question already here, but we'll answer at an appropriate moment. So we're saying that in inversion of control approach, objects know nothing about each other. This A doesn't know anything about B, and it is the container that it is taking the control. And it will say, okay, I have to create object B and initialize it. Okay, I have to create object A, I have to initialize it and inject the dependency between A and B. So it is the container that is taking control, and nothing in the sense of dependency, no dependency resides inside the code. How do we work with the Spring framework and with IOC containers? Here we have a global or overall picture. The Spring container needs two kinds of information. It needs the business objects or POJOs from here, and these ones are our classes, person and company, for example, that we have already presented. And we have this configuration metadata. What's this? This is the description of that application context.xml, where we were providing the configuration of the beans to be created. And the Spring container will have to put them head to head. It means that the metadata or the beans to be created will need to be combined with the POJOs. They need to match, so that we need to instruct the container to create beans that correspond to those classes. Putting them head to head will result in a fully configured system ready to use. This is what we have already seen. And we'll go back to show again. Give me one moment. Here we had the person and the company. Those were the POJOs. They needed to be put head to head with the information from here. And what resulted was this fully configured application where we were able to ask, give us Smith and tell us which company this Smith is working for, and we are getting here Luxoft. There was a question here saying if we can test that container is correctly configured. Does it make sense to have such tests? Let's see if the examples that we are going to present now will also answer to these questions, to this question. Otherwise, we may detail a little more by the end of our session. So I'm going to present and discuss a few possibilities to create objects and we'll work with this inversion of control in order to get the correct dependency injection. Let's see here, just a moment, to see what we do have here. We do have a simple bin, so it just has a value and getter and setter for that value. We have a compost bin, meaning that it contains that simple bin and it has a getter and a setter for it. And we have this constructor injected bin. Here, if we look at the compost bin, we see that this simple field is initialized through this set simple method. So the compost bin doesn't declare any constructor. It will mean that it is the compiler that will create the no arguments constructor for us. We have a compost bin created, and then we set it. We set the simple bin inside this compost bin. Here, with the constructor injected, we see also that we have a simple bin inside, but we no longer have no arguments constructor. We have a constructor injected that is getting this simple bin. And it means that the constructor injected will need to get simple bin as argument of its constructor in order to get it ready, to get itself ready. Let's see how these things look like at the level of our XML. I will kindly ask you to have a look here for half a minute, and then I will start explaining. Okay, so we see here that we have this simple bin created. We are defining it, and we are saying here property name value. This will mean that the container will have to look for a property name that is value, and it will find it here. And it will create this simple bin and set it saying value is spring is fun. What does it mean? Here, if we have a look, let's just comment out for the moment this piece. What are we saying here? We are asking Spring to have a look for a context on the class path called application context XML, and it will find it here. And from here, Spring will create and load these bins and make the dependencies between them. And then we are asking, give us this simple bin belonging to this class and tell us which value it has here. And if we run this application now, we see that it has created this bin, and it has printed Spring is fun. It is also creating that constructor injected because it is into the container. What do we have to understand from here? Yes, you see, we have this definition of this simple, and it has to have a property value. And I'm getting back now to this question that we have previously received. It was saying, how can we test that container is correctly configured? If we would like to force our luck, and let's say that we would like to incorrectly test, to incorrectly set this simple bin, and let's say that we have property name and I presume by mistake we're writing his name incorrectly. This means that the container is incorrectly set. So if we are running this here, we see that we are getting an error. So what we see here is that we have tried to incorrectly set up the container. We have first it to create that simple bin object with this invalid property value E that does not exist. So if we try to incorrectly set the container at runtime, we are going to immediately get an error. We don't arrive to any further step. If the container is incorrectly configured, meaning that we talk about classes that do not exist, we talk about setting properties that do not exist, or so on, we cannot even start the application. The application will fail just from the beginning. We will not be able to arrive any further. So we remind you that the correct configuration was with value here, corresponding to simple bin here value, get value, set value, the getter and the setter, and this is the correct configuration that our container was expecting. This is the simple bin. Let's have a look at this composed bin. We see here composed bin corresponds to this class. So if we look here, we have a private simple bin inside, and we see here that we are setting this property name referring to this simple bin. And let's say that we are forcing here also by mistake to reference to some inexistent bin. The property name is correct, but this reference is wrong. So you see, we are getting an exception, say no bin named simple2 is available. So any incorrect configuration of the container will result in an immediate failure, and we cannot start the application. And let's try something more. We have taken a look at this simple bin, at the composed bin, how it is created. Let me see, we also have a question here. Reference to wrong instance. I am asked about a reference to a wrong instance. I'm trying to understand what this means. So I understand from the question, if I have correctly understood what it means. I understand that the reference to some instance is set. That instance exists, but it is not the correct one. So the business logic will mean that you are looking for some other instance to be referenced. This must be tested at the level of the unit test or of the integration test eventually. let's try to demonstrate something here. We do not have JUnit tests, but we will try to show something that will get close to this. You see here that I'm printing simple get value here, and I'm printing the composed get simple dot get value, and we are expecting, if it is simple here that has been injected here, to get also Spring is fun. And when we compare these references, what has been injected into the composed is exactly that simple bin. Let's see how it works. So we see that we have Spring is fun. This is the text printed by this line of code, simple get value. Spring is fun, and this is printed by this line of code, compose.getSimple.get value. And when we ask compose get simple, is it the same reference as simple? We are getting true. But let's go further on what has been asked. And let's presume here that we'll also have a bin called simple2. We are configuring it this way. We have here to ask, as long as we do not have only one single bin of type simple bin, we are going to ask for the simple2. And here we are injecting this one. Instead of injecting this simple, here we are injecting this simple2 here. But we are still making this comparison. So we are forcing here a business logic error. Let me see what. No unique. Just a moment. Let me. Just a moment. Okay. Because we have two bins of the same type. Okay. What we see here we see that we have the same message here, but it belongs to the simple2 bin. It belongs here. So if we have injected this simple2 here, it means that we are no longer getting the previous message Spring is fun. We have added another bin of this type simple bin with another message. We have injected it here, simple2 instead of simple. And when we have run this, we have seen that different message. And it is here where our unit test, JUnit, may come and say we are expecting the message spring is fun, and we are getting spring is really fun. It is here where we may do this testing if this is what you are asking about the business logic. We may configure the container. We may ask, give us these beans, let's put them together, solve the problem. And when we check the result of solving the problem, we see that it is not what we are expecting. Here, we do have a different message. This is, I think this is what that question meant. We have to test the business logic just like any other business logic, with Spring or without Spring. The business logic still has to exist and to be correctly followed if we would really like our application to run correctly from the business point, from the business logic point of view. Okay, let us demonstrate something more here. At the configuration level, if we have a look here into this constructor injected, we see that this constructor injected class does have a simple bin argument. And we made sure here that when we have created this bin constructor injected, we passed this constructor argument to it. What would happen what will happen if we do not mention it here? Let's say that we remove this constructor argument. This is another type of error in the container configuration, but not a business logic error. You see, we are getting an exception at the initialization of the container. What is it saying? Failed to instantiate, no default constructor found. What does it mean? It means that here at the level of the container configuration, as long as we do not mention any constructor argument, the container will look for no constructor argument. And if it goes here, it will not find that no constructor argument. We have a constructor with one argument, and we say, oh, this is a technical error at the level of the configuration. I cannot create such a bin because a constructor with no argument simply does not exist. So I don't know how to handle the instructions that you have provided to me. It means more exactly that this class does not match the configuration. The class has one constructor with a simple bin argument, while the configuration is forcing the container to look for a no arguments constructor. And these two things do not match. Let's go back here and remake our existing configuration. And if we run again this application, we see one thing is that it works. And we see this message that we haven't explained so far. Constructor injected. Where does it come from? We see here that besides the configuration, the container is instructed to have this init method. So it means that it will create this bin, and after creating this bin, it will go and execute this init method. And this init method will send constructor injected. Let's try again to force our luck here. And let's say that by mistake, we have configured this container in a wrong way. We are looking for init method called init2. Running it. Again, we are getting an exception, and it is saying, could not find an init method named init2. So it does not exist, of course. So you see that from the technical point of view, the container cannot be configured in a wrong way because it will simply stop the application. From the business logic point of view, it will be our responsibility to correctly configure it and to test that once it is configured in some way, it will produce the correct results. What we have to add here is that everything that Spring is doing, looking for property names, value, looking for a constructor with some arguments, looking for an initialization method called init, is done through reflection. Reflection is a technique that allows us to inspect or to introspect into the classes, into their methods, into their constructors, into their members in general at the level, at the time, at the runtime, at the level of the runtime. So doing these things in the background through reflection, Spring will identify if the container is correctly configured, if some property exists, if the constructor has received the correct argument, if some method really exists. Let me see what we have here. Another. Yes, it is possible to lazy instantiate objects. What we have seen so far is that the default behavior is that all objects are created at the moment when the container starts. Let's prove this once again. So we are going to comment these things, and we are going to simply create the context and make sure that it closes. And we are executing this. You still see this message, constructor injected. Why? Because everything that is declared here is created right at the moment of the starting of the container. If we would like to force, let me see here, lazy init equals true, it means that this bin will not be created until first addressed. And if we run the application again, we see nothing more is displayed. Let's try to do the following. Ask about this bin. Constructor injected. Just a moment to see that. And we are getting it from inside the container. And here it is called exactly constructor injected. And we are rerunning the application. So we get the message again because this constructor injected is created when it is first accessed. Here, if we remove it, we try to run again. Remember that this has been lazily instantiated. It is not instantiated any longer. Still have here some question. Can we add print to constructor to see if this is executed or not? Let's add some print the constructor here. Okay, compost bin. And here into the constructor injected. Okay, we have added messages to all three constructors that we have here. And let's have a look at this application. So we see here that we do not call any bin from inside the container. We just create the context, meaning we're creating the container and we are closing it. Let's see what happens. You see, we are creating simple bin constructor, composed bin constructor. If we have a look here, we see that we have simple bin, composed bin. All of them are not lazy, so it means that they are created at the startup of the container, while this one being lazy, it is not created. Let's go here and put here too lazy in it. We should expect that we only have this composed bin now created. It is created here, And this is also displayed because we have here reference to simple 2, and it has to be created in order to inject it here. So we have only this one and this one created, this one not directly, but through Compost bin. And let's say that we have here also lazy init true. So all bins are lazily initialized. Nothing is displayed. So the container will no longer hurry up in order to say, okay, I have to create these bins. All of them are lazily initialized. Okay, let's take 1 minute for you to, maybe you think that you would like to do some more variation of this example. We may go to the questions and answer in a little time. Let's take a minute if you still want to do some variation on this example. Okay, let me have a look at the questions that are. Where should we put heavy init logic? In the constructor or init function? Yes, indeed, rather looks like into the init function. If you put it into the constructor, it means that it will always be executed by no matter which bin of that type is created. So one thing is that if you create 10 bins of that type, you will have no possibility of variation. All 10 constructors will be executed doing the same thing for all 10 objects. Another argument to put it into the init function is that if it is a heavy initialization logic, then sometimes you may call it, sometimes you may not call it. Anyway, it is something really heavy to be executed, and it should be rather separated. You will have this flexibility. You will simply go here and say, okay, now I would like this init method to be executed. Now I would like this init method not to be executed, or maybe we may even have more than one initialization method to be executed to make some variation. So we have a heavy initialization logic for some types of bins and some other heavy initialization logic for some other types of bins. You tell me if this answers your question, if you would like still. Okay, looking forward for some other questions. What do you mean by lifetime policy? I do have some. Yes. So we may have here initialization method and destroy method. Let's add this. And let's create this destroy method here. If we simply execute it now, nothing happens, but remember, everything is lazy. They are not created. If we eliminate this lazy from here, you see, our constructor, our container will fail. Say, I cannot find a destroy method named destroy. So it has created, you see that it has created the bins here. And when the application has finished, it has to close the container, and it is looking for this destroy method. And now it sees that it does not exist, so it is throwing an exception. Let's do this. Let's create this destroy method. Okay. You see, this time it has found the destroy method and it has executed it. Not only that the application is correctly running, no exception is thrown as long as the configuration is correct, but also this destroy method is executed. You tell me if this answers your question, if there are any other questions, anything that you would like us to demonstrate together. What happens if we overload the init method? If we overload the init method, we have to, if it is overloaded, it has to go with no arguments. Int x with some other types of arguments. In order to overload it, we have this no arguments, and we have this method with another type of arguments. Let's say constructor injected init method overloaded. And here, just to say, init method. I think we also have to, you see here, constructor injected init method. Why? Because it will always look for a no arguments method. Here, everything that it knows is that it has a no arguments method. No matter how many methods are here, the one that is executed is the one with no arguments. Okay, anything else that you would like to show Anything else that you would like to ask?
Okay, if there aren't any more questions, Catalin, thank you very much for your presentation and for facilitating this webinar. Everyone, thank you for taking part. We kindly ask you to take a couple of minutes of your time and complete the link we've given you to just give us your opinion about the webinar and what other subjects you would like us to host webinars in the future. In the next couple of days, we will be uploading this webinar to our YouTube channel, and we will get back to you through an email with a link where you can view this webinar. So this concludes our webinar for today. Thank you very much, everybody, for taking part. Catalin, thank you for facilitating, and we'll keep in touch with regard to our next webinar and when we will be uploading the registration of this webinar. Have a nice day, everyone.
Thank you.